How are you, my friends? This is review questions number 2 on pre-calculus topics related to lectures 17 to 32. Question number 1, given the function f of x is equal to tan absolute value of the x, graph the function and find the interval or intervals where the graph is below the x if x belongs to minus 3 pi over 2 to 3 pi over 2. So graphing this function is easy. Since we have an absolute value on the x itself, we can consider two cases, x positive and x negative. X positive, then the absolute value will be the same as x, so y will be tan of x. So here on the right side where x is positive, you just draw the tan, just normal tan here. If x is negative, the absolute value will be minus x. Tan of minus x will be minus tan of x. So there is a reflection here about why x is reflection of this. See? Now, we look where we have minus 3 pi over 2 to 3 pi over 2. We need where the graph is below the x. Below the x is from minus pi to minus pi over 2, that's below, union from pi over 2 to pi. That is the answer. Question number 2, we have a nice identity here, 1 over 1 minus sine of minus theta plus 1 over 1 plus sine of minus theta. Let's make this one similar to A over B plus cosine of c theta. After that, you find A plus B plus C. So let's start on the left side here. I know sine function is an odd function, so sine of minus theta becomes minus. Sine theta with the minus here becomes plus. Sine of minus theta is minus sine theta. Combine the fraction here by the LCD. Just put 1 plus sine of theta times 1 minus sine of theta. So from the previous slide, we have 2 over 1 minus sine squared of theta. I can replace that by 1 minus sine squared of theta will be cosine squared of theta using this fundamental theorem. Now, the lowering power also, cosine squared of the x will be 1 plus cosine of 2x divided by 2. So I can replace cosine squared of theta, 1 plus cosine of 2 theta divided by 2. Then I divide here two fractions. Remember the formula? A over b divided by c over d will be a over b times the reciprocal here, d over c. So it will be 2 over 1 times the 2 divided by 1 plus cosine of 2 theta. So this will be 4 over 1 plus cosine of 2 theta. So instead of cosine squared, we change that into 4 over 1 plus cosine of 2 theta. Compare that with the given in the question here. So A will be 4, B will be the 1, and C is the coefficient of theta. C is 2. So when you add A plus B plus C, you get 7. Question number 3 is an easy question. Find the exact value of cotan of all this inside, big bracket, divided by cosine of tan inverse only 4 over 5. So we can do each one separate. Let's call this n over d. This is the numerator and the denominator. So n will be cotan of all this. Let's go inside and see our cosine will be cosine inverse of minus 1. What is the angle from 0 to pi, whose cosine is minus 1? It's the angle pi. Sine inverse of 1 will be pi over 2, and there is a minus here from the question. Plus tan inverse of 1, that's the easy angle, pi over 4. Add all these three angles, you get 3 pi over 4. That's an angle in quadrant 2, and the cotan is minus 1. So the whole numerator here is minus 1. That's easy. Now for the denominator, we have to say let theta is equal tan inverse 4 over 5. So tan theta will be 4 over 5, which is y over x. I can find r will be square root of 41. So what do I need to find? Cosine of the theta. Cosine of the theta will be x over r, which is 5 over square root of 41. This is in the denominator. So the whole expression equals minus square root of 41 divided by 5. Question number 4 is a nice question. Tan of minus a is equal minus square root of 35, where a between 2 pi and 5 pi over 2. Find the value of sine half angle a over 2. Now we know sine u over 2, this is the formula here, plus or minus 1 minus cosine of the u divided by 2. And I need sine a over 2. So from there, I can find cosine of the u because I have to use it in the formula. So tan of minus a is equal minus this. You know, this is an odd function. So minus tan of a will be minus square root of 35. Cancel the minus. Tan of a will be square root of 35, which is square root of 35 over 1. So that will be y over x. Then I can find r will be 6 because I need cosine of the a, which is x over r, 1 over 6. This is in quadrant 1. Now, a is given between 2 pi and 5 pi over 2. I have to divide by 2. So divide by 2 here, you get pi, a over 2, 5 pi over 4. So a over 2 belongs to quadrant 3. So the sign of the half angle is negative, remember. So I have to choose the minus here. And there is 1 minus 1 over 6. So it will be 6 over 6, 5 over 12. Simplify, you will get sine a over 2 minus square root of 15 divided by 6. Please check the numbers. Question number 5. Find the value of k if this system is inconsistent. Inconsistent, remember, you have to use the whole, any row like 0, 0, 0, and then here is a number. But if you have 0, 0, 0, and 0, then the system has infinitely many solutions. The question number 5, solution. We start with the augmented matrix, which is given here, and we try to make the last row zeros. So we take this 2 here, multiply row 1 by minus 2, and then we will add to row 3, as mentioned here. So minus 2 times 1 minus 2 plus 2, this will be 0. Minus 2 times 3 will be minus 6 plus 10. It will be 4. Now we need to expand this k minus 1 squared. It will be k squared minus 2k plus 1, remember. And multiply minus 2 times the 5 becomes minus 10. And there is a plus 1 here, so it becomes minus 9. We do the same thing for the other number. Multiply minus 2 times k, then you add here. Now, I have here 0 and then 4. I can use row 2, multiply by minus 2 also, and then add to row 3, so it becomes here 0. So you multiply here minus 2 times 2, minus 4 plus 4, 0. Minus 2 times minus 2k, 2k. When you add here, you can cancel the minus 2k. Then you are left with k squared minus 9. The same thing you do for the other term here. Now, check now the last row. We must have 0, 0, 0. See, the condition in the question is it should be inconsistent. So 0, 0, 0, and then a number here. So I take k squared minus 9 is equal to 0. I factor it. K minus 3, k plus 3. So k can be 3 or k can be minus 3. I have to check each one. K is equal to 3. If I replace it here, I will get 0, 0, 0 on the last row. And then here I put 3. I can factor it so that I can see easily here. K plus 3, k minus 2. Put k is equal to 3. 3 plus 3, 6. 6 times 3 minus 5 minus 2, that will be minus 12. So 0, 0, 0 minus 12. That will be inconsistent. Now let me check the other one. k minus 3. It will be 0 also here, because minus 3 all squared is 9. 9 minus 9 is 0. If I put here minus 3, I will get 0. So 0, 0, 0, 0. This is infinitely many solutions. So this is rejected. So the only value for k is k equals to 3. Question number 6 about vectors. Given two vectors, C and D. C is given minus square root of 3, k minus 1. D has the magnitude 6 and direction angle 11 pi over 6. So we have to find the vector D. The question is find k if the vector C minus D is orthogonal to the vector J minus square root of 12i. Orthogonal means perpendicular. So first we have to find the components of the vector D. Using this formula here, any vector u can be written as the magnitude of u cosine theta, magnitude of u sine theta. So I can write vector D, 6 cosine 11 pi over 6, 6 sine 11 pi over 6. I put the values here. 11 pi over 6 is in quadrant 4. So the cosine is positive, square root of 3 over 2, and the sine is negative, minus half. So the vector D now becomes 3 square root of 3 minus 3. Now let the vector T is equal to C minus D, because I need to subtract here C minus D from the given. Let's call it T, the vector T. Also in the given, we have vector J minus square root of 2i. Let's call it vector R. But remember, you have to rearrange R. Square root of 12, you can write it as 2 square root of 3, there is a minus, and then the coefficient of J is 1 here. So this is vector R, and this is vector T. They are orthogonal, means they are perpendicular. That means the dot product T dot R is equal to 0. So first I find T. T means C minus the D. Just subtract these two vectors, you will get minus 4 square root of 3k plus 1. Now find the dot product. So you multiply AC plus BD. Minus 4 square root of 3 times minus 2 square root of 3 here, plus k plus 2 times the 1. You will have here very simple linear equation. So k will be minus 26. Question number 7. Solve the trigonometric equation. Sine 2 theta is equal to square root of 3 cosine of theta. As you see here, there is no condition given in this question, so we have to find the general solution. I start by putting the formula for sine 2 theta. 2 sine theta cosine theta. Take this term, square root of 3 cosine theta, on the other side to make it 0 on the right side. Then we can take cosine of theta as a common factor. Just a note here, please. You cannot divide by cosine of theta because you are losing some solutions. So cosine of theta is equal to 0, or sine of theta will be square root of 3 over 2. So we have to look now for the angles in the basic period of 2 pi for sine and the cosine. Cosine theta is equal to 0, then theta will be pi over 2, and theta will be 3 pi over 2. We call these quadrantal angles. If sine theta is square root of 3 over 2, then theta will be pi over 3 and 2 pi over 3, because this is in quadrant 1 and 2, the sign is positive. Now there's a little note here, pi over 2 plus 2k pi, because the period for sine and the cosine is 2 pi. So pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi can be written as pi over 2 plus k pi. This is an easy way to write these two solutions together. Now, all the solutions, we need to find all the solutions, the general ones. It will be pi over 2 plus k pi, because I combine these two together. And I have here pi over 3 plus 2k pi, and theta 2 pi over 3 plus 2k pi, where k is integer. Now, question number 8 is about nonlinear system. Solve this. X squared minus xy is equal to minus 4. Xy minus y squared is equal to minus 5. So the first equation, I will call it number 1. The second, I will call it number 2. I start solving equation number 1 here. Solve for y. So I take xy on the other side. I bring -4 on the other side also. So y will be x squared plus 4 divided by x. Let's call this one star, and we replace star in equation 2. Now be careful here. X times the y is x squared plus 4 over 4 minus y, all this we make it squared because we have y squared is equal -5. Now you have to rearrange the equation. You can do it the way you like and the easiest way. Cancel the x here. We get x squared plus 4. Here we split the power to x squared plus 4 all squared divided by x squared. So we have to do here two things. We need to multiply by x squared the whole equation. So this will be x power 4. And here we have 4x squared. I take it on the other side, there is -5x squared. So it becomes -9x squared. And this one all squared with the minus outside. Now I can expand using the formula from algebra, a plus b squared, a squared plus 2ab plus b squared. So that will be x power 4 plus 8x squared plus 16 is equal this. Now we continue in the next slide. Simplify the equation, you will get easily x squared is equal to 16. So x can be 4 or x can be -4. Now to find y, let's go back to equation star because it's ready. You can go to equation 1, you can go to equation 2 also. So y will be x squared plus 4 divided by x. Put x equals 4, you will get y 5. Check it, please. Put x equals -4, you will get y -5. So you have to check in every nonlinear system, check each proposed solution in the original system. I put here for you the original system, easy to see. I put the first point, 4 and 5. You check it in each equation, and then the second point, -4, -5. Both points are acceptable, so we can write the solutions are 4, 5, -4, -5, 2 points. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.